Hi, this is Melissa Fowler, and I'm going to be doing a lecture on basic drug calculations. Now, there are really three ways to do drug calculations, and that is the desired over have formula, and the ratio method, and dimensional analysis. And I noticed that the majority of textbooks is moving more toward dimensional analysis. I'm going to teach you all three ways, and you can decide which way works best for you in your brain. As we get a little more advanced in some of our more advanced IV calculations, I noticed that dimensional analysis really works best. But again, you kind of decide for yourself. So we're going to start out really elementary. And by that, I mean, I'm going to ask you a question of just converting between grams and milligrams and liters and milliliters. This is something, and I'm going to show you the different ways to do that with these really basic calculations. So if I'm wondering how many grams there are in 350 milligrams, well, a lot of you can just look at that and know, how many grams there are, but I'm going to show you the different ways to calculate that using ratio and dimensional analysis. So we have to know our basic conversions, which is that 1 gram equals 1,000 milligrams. And I'm going to show you the ratio method first. And so we want to know if 1 gram equals 1,000 milligrams, then we want to know how many grams. So I'm going to say like X grams is going to equal 350 milligrams. So again, 1 gram equals 1,000 milligrams equals, because this is a ratio, how many grams over 350 milligrams. Now when you have a ratio method, you're going to cross multiply. And so if I do that, you get 1,000x equals 350. And then if you divide 350 by 1,000, you're going to get 0.35 grams. So that's how to do that with the ratio method. A lot of people can just move the decimal over the 3 points, either to the right or to the left too. And you can do that. You might get yourself in trouble with that sometimes if you move it the wrong way. So be aware. Okay, what about if I'm going to do dimensional analysis? So with dimensional analysis, I'm going to times all the top and times all the bottom and get to the end. So I want to think about what I want to end up with. What I want to end up with is grams. And so I'm going to keep my grams in the numerator spot. Okay, so I'm going to set up my ratio again, which is 1 grams equals milligrams, 1,000 milligrams. And this isn't a fraction, this is just more like a relationship, okay? So I want to think about what I want to cancel out. Well, I want to cancel out the milligrams because I want grams. And so I'm going to put my milligrams on the top here, 350 milligrams. That's what we know. And we don't know what the grams are, right? That's kind of like an X, or that's what we're trying to solve for. And with dimensional analysis, like I said, we're going to times the top and we're going to times the bottom all the way across. And we're going to cancel out anything that's on the top or bottom that's the same, okay? This really is just X, okay? It is a gram, but that's what we're trying to solve for. So if I'm timesing this across, it would be 350 over 1,000 equals, and then it's the same. You're going to get 0.35. What? Well, our X that we're trying to solve for is grams. Or you can say, what's left over, what unit of measurement is left over? Grams. Okay. So that's how to do it through dimensional analysis. And I'll show you a little more of an in-depth one in a minute. Okay. How about if we're using conversions between the metric system and the household measurements? So let's say we have 4 ounces and we want to know how many milliliters that is. Okay, so we have to memorize our basic conversions of our household equivalence, and 1 ounce equals 30 mils. That's just the rule, right? That's the standard. And so that's not going to change. And what we need to know is now how many, for 4 ounces, how many mils is that? Now a lot of you guys can just look at that and figure it out. I get that. But I want to teach you at a really basic elementary way, and so that you can apply it to more difficult problems, okay? So if we're doing the ratio method, right, we are going to do 1 ounce over 30 mils equals 4 ounces over X mils. And you think about, remember with the ratio method, we're keeping the units the same. It's not like we're trying to cancel them out like dimensional analysis. And so we're going to cross multiply. So we're basically X, because that's 1X, equals 4 times 30 is 120. And we're looking for mils here, right? So 120 mils. So that's how many mils are in 4 ounces, okay? If you do dimensional analysis, sorry, I erased some of that. If you wonder, well, how am I going to know this on a test? I'm not going to give you this measurement. You have to know. There are certain things you have to memorize, like kilograms and pounds and ounces and mils, okay? So if you're doing dimensional analysis, remember we want to keep the mils on the numerator because that's what we want to end up with. So 30 mils is 1 ounce, and we kind of do a little times or a little dot. That means that we're going to times the top and times the bottom. So we want to get rid of the ounces because we want to end up with mils. We're wondering, oops, let's do everything here. How many mils is in 4 ounces? And so we want to put our ounces up here because we want to cross multiply and get rid of the ounces. So 4 ounces up here over, we'll say X, because we want to know how many mils there are. So we're going to cancel out the ounces and times across the top, which will be 120, and the bottom, which is 1, equals 120. Well, what's left over? Our ounces are gone, so it's the mils that are left. So 120 mils. You can see where you get the same answer, you just do it in different ways. And so you can decide what works best for you and your brain. Or you may decide to do the problem in the ratio method and then check your answer with dimensional analysis. Okay, next thing is pounds to kilograms. Very common thing that you're going to need to do a lot. So what's the thing that we need to memorize? 1 kilogram equals 2.2 pounds. I would be careful with this LB because sometimes that can look like 1, and then sometimes you can get yourself into trouble there in terms of calculating. Okay, so if I want to know how many kilograms is in 110 pounds. Okay, how many kilograms is 110 pounds? So let's start with the ratio method. Ratio method would be 2.2 pounds over 1 kilogram. That is our standard, or our standard conversion that never changes. And it equals, well, what do we want to know? We want to know kilogram. We're putting kilogram down here. X kilograms, 110 pounds. Okay, and then because it's the ratio method, we're going to cross multiply, and we get 2.2x equals 1 times 110, and 110 divided by 2.2 equals 50 kilograms, okay? Because that's what we wanted to know, kilograms. All right, I think you guys are starting to get the hang of it with dimensional analysis. Oops. Sorry, I erased that thing. How many kilograms is in 110 pounds? Okay, so with dimensional analysis, again, we want to end up with kilograms, so I'm going to keep my kilograms in the numerator. And 1 kilogram is 2.2 pounds. Now again, I want to get rid of the pounds, and so I'm going to keep my pounds up here so that I can cross multiply. 110 pounds over X, because we want to know how many kilograms. So now we times across the top, 110, and we times across the bottom, 2.2, because that's a 1, and we end up also with 50. Well, 50 what? What's this X? Kilogram. Or we could say, what's left over? The kilograms. Okay. All right. I know some of you are rolling your eyes saying, this is so easy. Let's get into the hard stuff. Milk before meat. We're not going to go crazy, but I will show you just a little more of a difficult problem. Let's say you have, well, let me introduce you to the desired over half times the vehicle calculation. So what does this mean? The desired is what you want to give to the patient. It's like the doctor's order. You can also think of D as the doctor's order. The have is what you have on hand. So you can say on hand. You can think of it as what's on the vial label or the package. Okay, so this is what we want to give the patient, but this is what's either in the vial or the package, and we have to think about a conversion, how to convert that to what we're actually going to give. And then the vehicle is like how it comes, we could say. How it comes. So if it's in mils, or if it's like a tablet, it's like how many of them we're going to give, or how much we're going to draw up in the syringe. Okay? So let's say the doctor's order says drug A, I didn't choose a drug, I'm going to say drug A, 1,000 micrograms, IM times 1 now. Now, we don't really care about all these extra numbers and things. This is really what all we care about with doing a drug calculation. And how about the vial or the package says drug A is 2 milligrams per milliliter. So how many mils is the nurse going to draw into the syringe in order to give this IM injection? Okay, so let's plug some things in. Now notice we have a milligram microgram issue here. So we want to try to change this to what's on the drug label. We want to change our micrograms to milligrams. And so we can easily move this over, 1, 2, 3. And so we're now in milligrams. Let's say the doctor's order now is really 1 milligram. And you could do that via the ratio method, again, like we just talked about, or dimensional analysis, or you can just look at it and move your decimal over. Okay, but 1 milligram equals 1,000 micrograms. So the order, this is the doctor's order, right? Where is this going to fit here? It's going to fit with the D of the desired over half. So we're going to put 1 milligram as the numerator. So what's our have, our H? What do we have? It's what's on the label. So on the vial, it says there's 2 milligrams per milliliter. And so we're going to put the 2 milligrams down here. That's how many milligrams we have. Now, what's the vehicle? The 2 milligrams comes in 1 mil. Okay? And because we have milligrams on top and bottom, we can cancel that. And so that's 1 over 2 times 1. So okay, 1 over 2 is 0.5 times 1 is 0.5. 0.5 what? This is the only thing that's left, and that's what we wanted. Mils. So 0.5 mils is what the nurse is going to draw into the syringe in order to give 1 milligram of drug A. Okay? So that is a really simple drug calculation on how to use desired over have. All right, one last let's say this patient actually has 2 orders. Colace, 300 milligrams, POBID. Okay, Colace is docusate. That's the trade name for it. Amoxicillin, 25 milligrams per kilogram, PO at 8 o'clock daily. Okay, there's a lot of extra numbers in here, but really we're more focused on just what the dose is, because that's going to help us with our drug calculation. Let's start with the Colace, okay? Now we can easily just do we can actually use desired over have, the ratio method, and dimensional analysis with both of these. I'll show you Colace with desired over have, and then I'll show you amoxicillin with maybe a couple different ways. So Colace, what is our desired? Our desired number is the doctor's order. This is the doctor's order, 300 milligrams. That's our desired. Well, what's our have? If you look over here, I have a little bottle that I drew. So the bottle says that there's 150 milligrams per tablet. So what we have is 150 milligrams. What's the vehicle? 1 tablet. And then you just do that calculation. 300 divided by 150 is 2, and that cancels out. Times 1, you'll end up with 2 tablets. So if the doctor's ordered 300, you have 2 tablets. And I know a lot of you are saying, like, well, I could just look at that and say, you know, figure that out in my head, and that's fine. But as they get more complicated, it's good to have good calculation methods and good habits that are going to get you the right answer. Let's move to amoxicillin, because that one's just a little more tricky. Okay, I'm going to show you this in dimensional analysis because there are multiple steps involved in this one. So remember, if we're doing dimensional analysis, we want to think about what we want to end up with, which is how many mils we're going to pull up. Okay, so we have, I need a little more information here. This patient's weight is 32 pounds. Okay, let me get a little piece of paper. Maybe not. Oh, here it is. Okay, so remember with dimensional analysis, we want to have something on the top and something on the bottom that we want to cancel out and get rid of. And so think about, I always start with my pounds. It always seems to work out just fine. So if we have a patient that's 32 pounds, and we're just going to put that over 1 because it's not really related to anything, we're going to times that by something pounds down here because I want to get rid of pounds. So we have our normal measurements equivalence, which is 2.2 pounds equals 1 kilogram. You know that. So I'm going to put 2.2 pounds over 1 kilogram. Okay, now I can get rid of the pounds. Now I still don't really want kilograms. I want to end up with mils. So I'm going to put kilograms down here. Well, what do we have here? We have an order, 25 milligrams per kilogram. So let's say 1 kilogram over 25 milligrams. Now we can get rid of our kilograms. Now we have some more because we still don't have mils, and that's really what I want because I want to know how much am I drawing up of amoxicillin to give to my patient. So we're going to look at the bottle now. This is our have. Amoxicillin's 200 milligrams per 5 mils. So I want to get rid of those milligrams here. So I'm going to put 200 milligrams over 5 mils. Now I can get rid of my milligrams. Now I finally have crossed out all of my units of measurement until I'm left with what I really want, which is mils. So now I'm ready to do all of this multiplication across the top and all the multiplication across the bottom. I did calculate this. You would just do 32 times 1 times 25 times 5, and you end up with 4,000. And then we did 1 times 2.2 times 1 times 200, and we end up with 440 equals, it's like 9.09, I think, but according to rounding rules, we will round to the 9.1, and what's left over, mils, and that's mils. So according to this patient who's 32 pounds and who has a doctor's order of 25 milligrams per kilogram, we're gonna give 9.1 mils. And that's a really, I think, a lot easier way to do this whole problem as opposed to calculating the kilograms from the pounds and then plugging it back into the order and then getting your desired, but you can absolutely do that. I'll show you and we'll see if we get the same answer. One more way. So if you're trying to figure out a pounds to kilogram desired over have problem, you want to start with converting the pounds to kilograms. So we can do the ratio method with that, right? Okay, so if we have our 1 kilogram over 2.2 pounds equals really X kilograms, right? Because we want to know how many kilograms is equal to 32 pounds. Because it's the ratio method, we'll cross multiply and we'll end up with 2.2x equals 32. X equals 32 divided by 2.2, and x equals, what did I get? 14.54, and I think it keeps going, okay? And so that's the kilogram. Well, what do I do with that number? You're gonna plug it back in to the doctor's order, because if the doctor wants us to give 25 milligrams per 1 kilogram, but our patient is 14.54 kilograms. So what do I need to do? I need to times this number by 25 milligrams, okay? So if you do that, 25 times, better do that. So 14.54 times 25 equals 363.5 milligrams. The reason why it's milligrams is because we want to know, we're going to give a certain amount of milligrams per kilogram, 25 milligrams per kilogram. So we're going to give 25 for each 1 kilogram, but because our patient's 14 kilograms, we're going to give 363.5 milligrams. Now, this is our doctor's order, or we could say this is our desired. Okay, so this number is going to pop into our desired over have times vehicle. Okay, D equals, we'll say 363.5 milligrams. Now we're ready to do the desired over have vehicle calculation. So what's our have? We go back over to the bottle. What's on the bottle, what's on the label, what's on the vial, that's all have. And so we've got 200 milligrams times the vehicle. Remember, the vehicle is how it comes. 200 milligrams comes in 5 mils. You can cancel those milligrams and we're going to be left with mils. So we'll do 363.5 divided by 200 equals 1.8175 times 5 equals 9.08, which by rounding rules is going to turn into 9.1 mils. Pretty cool. We ended up with the same answer as our dimensional analysis. So you really can do it either way. You can calculate your pounds and kilograms first and then plug it back into the original order. and then do your desired over half, or you can just do your one long equation, which is dimensional analysis. Well, this is a good start for us, and if you have further questions, come let me know, come to my class or my office hours, or give me a call or send me an email. I'm happy to chat about it. We could do some more practice questions. Thanks.